Welcome to the notes for Mrs. Neller's double block algebra class. These are the notes for section 13.6 entitled Use Measures of Central Tendency and Dispersion. And today we're going to find the mean, median, mode, and range of a data set. So we will identify the measure of central tendency that best represents a data set. Now, mean, median, mode, and range, those should be terms that you're familiar with, that you should have heard before. But these are what we use to analyze data with measures of central tendency. So all four of these terms are grouped together and they're called a measure of central tendency. That's just the terminology that they use to refer to all four of these terms collectively. So the mean is the average of a numerical data set. And you know how to find the average. You add up all the numbers and you divide by how many there are. So you add up the numbers and you divide by how many you have. Okay. The median is the middle number of the data set. Think of the median in a road is like a cement, or sometimes it's grassy or it has trees, but it's like the big space that goes down the middle of a road. That's called a median. And that's the same for numbers. It's the number that's in the middle of the data set. And sometimes you don't have just one number that's in the middle. Sometimes you have two. Like if we had the numbers 0, 0, 1, 1, 2, 2, and 3, 3, then we have 8 numbers altogether, and the middle would be somewhere between the 1 and the 2. So then you take 1 plus 2 and add them up to get 3, and then you divide by 2 because there were 2 numbers. So then your middle, your median number, would be 1.5. So sometimes we're going to have to do that when we're finding our median. And that happens if you have an even number of numbers. If we had an odd number of numbers, then it would just be the middle number. The mode is going to be the value that occurs most frequently. So sometimes when you have a big data set, you have numbers that repeat more than once. So in that case, you might have one number that appears most often. Sometimes you might have two numbers that appear more than others, but the same as each other. And sometimes you might not have any number that appears most often. Sometimes all the numbers just appear one time. So you could have no mode, or you might have one, or you could have two, or you could even have more than that. You could have two or more. So it kind of depends on the data and the numbers that you have in your data set. Now the range is the last term of our central tendency here, and that's the difference between the greatest value and the least value. So it gives the length of the entire data set. And you'd want to know this so that you can see how far apart the data is. That's the main reason you would do this. So you want to see how far apart the data is. Sometimes you might be dealing with really big numbers that might be really, really far apart. Sometimes you might be dealing with a lot of little numbers, but they're really only maybe 1 unit apart. And it might also be good to know this so that you can graphically represent your data. Sometimes you need to know how big or how small to make your graph. Sometimes you need to make the increments a little bit bigger. You need to count by 50s or 100s instead of 1s and 2s. Or sometimes if you have a lot of information but there's only a range of 1 unit, sometimes you need to kind of zoom in and make your graph a lot bigger so that way people can see the subtle little differences. So the range seems pretty easy to calculate, but it has a lot of information and can be very useful. All right, so for example one here, we're going to find some pieces of information. Here we have the heights in feet of 8 waterfalls in the state of Washington. So here's the heights in feet of those 8 waterfalls. And they want us to find the range of the waterfall heights. Now, anytime we're dealing with central tendency and we're given a list of random numbers, we want to take a moment and we want to put them in order from least to greatest. So we want to put them in increasing order or ascending order. So my smallest number is 1,000. And then I have another 1,000 over here. So I'm going to put them together. My next biggest number is the 1181. And then I have 1191. I'm crossing them off as I go, just so that way I don't repeat any. Then I have 1,200. Oh, don't know why it does that. Okay, that was 91. Okay, then I have my 1,200. Then I'm going to have the 1,268. And notice that as you cross them off, it's a lot easier to put the remaining ones in order. So that's another good reason to cross off the numbers as you go. And that way you make sure you get them all. You don't miss any. But again, when you cross them off, don't completely black them out, because if you mess up, you have to be able to erase or still see what the number was. So just putting a little slash through it is effective enough. So now I have all my numbers in increasing order. So now I can tell what my biggest number is. That's the 2,584. And my smallest number is the 1,000. So to find the range, I'm just going to subtract those two. So 2,584 minus 1,000. You shouldn't need a calculator for that. You should be able to do that in your head. 1,584. So that's how many feet there are between the smallest of the waterfalls and the biggest waterfall. Okay, so that's a big number. So if you were going to graph this, that would help you to figure out how you want to count, how you want to organize spacing on your graph. Next, they want us to find the mean, median, mode, end mode of the waterfall heights. So remember that the mean is the average. So you definitely want a calculator for this, because we're going to have to take all 8 of these numbers and we're going to have to add them all up, and then we're going to have to divide by 8. So I'm not going to write this out, 1,000 plus 1,000 plus 1,181, and so on and so on. But if you do take a moment and you add up all 8 of those values that are written in blue, you should get 10,752. That's your total of all 8 of them. And then I'm going to divide by 8 because there were 8 waterfalls. So then my mean, my average, is going to be 1,344. Now notice that 1,344, that's my average, but if I put 1,344 into my data, it would fall right here. That's kind of near the high end of my data set. So we'll come back to that in a moment. The median is going to be the number that's right in the middle. And again, this is why we want all of them to be in order, from smallest to biggest, so that way I can find the middle number. And if you need to, you can kind of count backwards from both sides. But my 2 middle numbers, since I have an even number of numbers, I'm going to have 2 that are in the middle. So that means I'm going to have to add them up. So 1191 plus 1,200, add those up and then divide by 2. When I add those, I should get 2391. And then when I divide by 2, we should get 1,195.5. We're going to get a decimal here, and that's okay for the median. Sometimes for an average you might get a decimal as well, and that's okay. Now the median, if I put 1,195 in my data set, that would fall right here. And that's right about in the middle, so that's a good representation of all of my data. And then the next thing I'm going to find is my mode. And remember, the mode is the number that occurs most often. So here in the beginning, I have two 1000s, and then that's it. I don't have any other number that repeats. So here I have one mode, and it is the number 1000 because it repeats twice. All of the other numbers don't repeat at all. Now part C says which measure of central tendency is the best representation of the data. Now really we have four measures here because in part A I did find my range. But with my range, if I put 1584 in here, again, that would be between the 1328 and the 2584. So that's kind of at the high end. My mean is definitely at the high end, but my median is right in the middle, and it's close to a lot of the other values. I have some 11s, I have some 12s, and that's kind of close to an 11 and a 1200. Okay, but the 13 is pretty large, and the 15 is definitely larger than most of my numbers. So I would say here, in my mode, the 1000, that's really small. So I would say here that my median is the most representative. Okay. And it's the closest to most of the values. If they want a statement as to why, it's the closest to most of the other values. And this is a concept that can be a little tricky, and sometimes there can be more than one correct answer for these. Okay, but we want to look for a number that's not too big, it's not too small, like the range and the mean might be too big, the mode might be too small, but the median kind of fits right in the middle, and we have some 1100s and we have some 1200s, so it's a good representation of the data. Okay, so let's try this again with just different numbers, and we're going to talk about one other concept as we go through this example. Here we have the yearly salaries of 10 employees at a company. And again, I've got these salaries all listed out, and the first thing they want me to do is find the range. So before I even start doing that, I'm going to put them in order. So let's see here. My smallest is going to be the 3200. I'm sorry, 32,000. And then I have 35,000. And I kind of like how they have these stacked into two rows here. And then next is 38,000. And then I'm out of the 30s, so then I have 40s, but 43 is the smallest. And then 45. And then I'm going to make a second column, or second row as well. Then I also have 48. And then I'm out of the 40s, and then I have 50,000. Let me fix that. And then after the 50,000, I'm going to have my 52,000. And so far, I don't think I've had any that repeat. And then I've got 64. And then my last one is, whoa, 180. That's a lot bigger than any of the other ones. I started with the 32, and then I went from the 30s into the 40s and 50s and 60s, and then I jump all the way to 180. So this number here, when it is kind of really high or really low compared to all of the other ones, that is what we call an outlier. And the outliers have an effect on our central tendency measurements because they can make them too big or make them too small, depending on if you have a big outlier or a small outlier. So we'll pay attention to our mean, median, mode, and range as we go through the rest of these examples here. Okay. So my range then, And I'm finding my range. I'm going to take the largest value, so the 180,000, and then I'm going to subtract my smallest, the 32,000, and that will give me 148,000. Wow, so there's a 148,000 difference between 32,000 and 180,000. And that's salaries, that's money that people get. That's what they get paid. That's a big difference between them. Okay, so next we're going to find the median and the mean and the mode. So the mean, remember, that's our average. So again, you would want your calculator here so that you could take your time and you could add up all of these numbers. Now we have 10 numbers all together. So when we add them all up, we should get 587,000. And then we're going to divide by 10 because there are 10 numbers. So then we get 58,700. And again, that's dollars. That's the average. And then the median, that's going to be the number that's in the middle. Now again, we have an even number of numbers. So when you have an odd number, that's nice because it is just the one number that's in the middle. That's your median. But here we have an even number. So I'm going to have to use the 45,000 and the 48,000 as my two middle numbers. So I'm going to have to add them up and then take an average. And I probably won't get a decimal here because we're dealing with thousands, but I'll get an uneven amount. I'll get 46,500, which is an even number, but it's not a whole thousand. I have the 500 here. So 46,500, that's right in here if I was to add it to my list. So that's kind of in the middle of our numbers, or close to the middle. The 58,700, that would be right in here. That's near the high end of my numbers. And the 148,000 for my range, that's almost all the way to the top of my numbers. And then the mode, remember the mode is the number that occurs most often, and as I was rewriting all those numbers, I noticed that there weren't any that repeated. And if I go back and double check all 10 of these numbers, there aren't any that repeat. So here I don't have a mode. And that's okay. It's okay not to have a mode. So now part C is going to ask us again, which measure of central tendency best represents the data? And again, I think that number would be our median. Okay? The range is really, really big because of this outlier. And the mean is kind of pulled up towards the higher end of my data set because of this outlier. So the median, if I put that into my data set, it falls more in the middle, and it's at 46,000, and we had 3 values that were in the 40s. We had 3 that were in the 30s, 2 in the 50s, 1 in the 60s. So having a number in the $46,000 range is a lot more representative of the other numbers that are in the set, and it's not as affected by the $180,000 outlier. So here I would say that, again, the median is going to be the best representation of the data because it's not affected, or it's not as affected by the outlier. And sometimes you have an outlier and sometimes you don't. We'll talk more about the outliers when we start to do our box and whisker plots coming up as well. So that's a term that you will see more often. Okay, our last example then is kind of just a thinker. It's a more of a challenging problem, but they want us to create a data set. So that means we need to come up with it. And it has to have a mean of 10, so that's its average. It has to have a median of 10, so that means the middle number has to be 10. And it has to have modes of 5 and 8. So that tells me that 5 and 8 have to be the numbers that occur the most often. Okay? So since they tell me the median is 10, I'm going to kind of make my little middle spot here, and I'm going to put 10 into it. Now I don't know how many numbers I have, but I have to have a few on each side. And I have to have the same number on each side because 10 is the one median number. So that means 10 is in the middle. So I have to have one number in the middle and then even number on each side. So that way I can have a true single number that's in the middle. And next I have to have my modes of 5 and 8. So that means they have to both occur the same amount of times, but they have to occur more than the other numbers. So they can't just occur once. So they probably have to occur twice or 3 times. But if they occurred 3 times, I don't think 10 would be my median. So let's make my first numbers 5 and 5, and then after that 8 and 8. So that way the 5 and the 8 are occurring twice. And then the other spaces I'll fill in here with other numbers just one time. Okay, but now I have to figure out what those other numbers are going to be. Now I have to have an average of 10 as well. So that means I need to kind of think about how far away my numbers 8 and 5 are from 10. So when I'm dealing with the 8s, they're all 2 away from 10. So if I want to keep my average 10, then over here I'd have to have 2 numbers that are also 2 away from 10. And 2 units away from 10 would be 12 and 12. But I don't want 12 and 12 because then they would also be modes. Or I would have to change how many times 5 and 8 repeated. So I don't want 12 and 12, but I want numbers that will get me a total of 24 if I add the 2 of them up. So if I took 1 away from 12 and got 11, and added that extra 1 to the other 12 and made it 13, then I have 11 and 13 that add up to 24. So they would affect my average the same that 12 and 12 would. But I don't have the numbers 12 and 12 repeating. I have 11 and 13. I have single numbers that are repeating. So that keeps my modes of 5 and 8 occurring twice still a possibility. And now I got to think of the 5s. The 5s are 5 units away from 10. So then over here, I would need numbers that are also 5 units away from 10. So that way my average can be 10. So that means I would need 15 and 15. But I don't really want 15 and 15 because that would throw off my modes of 5 and 8 occurring twice. So again, let's do that same trick that we did before. Let me take a 1 away from this 15 and let me add it to the other 15, so I get 16. That way I still have a total of 30. Okay. So then if I added all these numbers up, if I added up the 5 and the 5, and the 8 and the 8, and the 10, the 11, the 13, the 14, and the 16, if I added them all up and divided by 9, I should get my average to be 10. So that's a way that I could check my work. And then I have a median of 10, that's my middle number. And the modes are 5 and 8. They occur most often. They both occur twice. The other numbers only occur one time. So it's a little bit of a process of guess and check, but you can be analytical about it. There is a little bit of a structure and a formula to it. So you will have a couple problems like these on your worksheet for tonight. So your homework is another worksheet. Remember, this isn't in the book. So try those problems. If you can handle those types of problems, then you have a good understanding of central tendency. And if you have any questions, come on in and see me before school.